Pickling is a metal surface treatment used to remove impurities, such as stains, inorganic contaminants, rust or scale from ferrous metals, copper, precious metals and aluminum alloys. A solution called pickle liquor, which contains strong acids, is used to remove the surface impurities. It is commonly used to descale or clean steel in various steelmaking processes. Many hot working processes and other processes that occur at high temperatures leave a discoloring oxide layer or scale on the surface. In order to remove the scale, the workpiece is dipped into a vat of pickle liquor. The primary acid used is hydrochloric acid, although sulfuric acid was previously more common. Hydrochloric acid is more expensive than sulfuric acid, but it pickles much faster while minimizing base metal loss. The speed is a requirement for integration in automatic steel mills that run production at high speed. Speeds as high as 800 feet per minute have been reported. Carbon steels, with an alloy content less than or equal to 6%, are often pickled in hydrochloric or sulfuric acid. Steels with an alloy content greater than 6% must be pickled in 2 steps, and other acids are used, such as phosphoric, nitric and hydrofluoric acid. Rust and acid-resistant chromium-nickel steels are pickled in a bath of hydrochloric and nitric acid. Most copper alloys are pickled in dilute sulfuric acid, but brass is pickled in concentrated sulfuric and nitric acid mixed with sodium chloride and soot. In jewelry making, pickling is used to remove the copper oxide layer that results from heating copper and sterling silver during soldering and annealing. A diluted sulfuric acid pickling bath is traditionally used, but may be replaced with citric acid. Sheet steel that undergoes acid pickling will oxidize when exposed to atmospheric conditions of moderately high humidity. For this reason, a thin film of oil or similar waterproof coating is applied to create a barrier to moisture in the air. This oil film must later be removed for many fabrication, plating or painting processes. Disadvantages: acid cleaning has limitations in that it is difficult to handle because of its corrosiveness, and it is not applicable to all steels. Hydrogen embrittlement becomes a problem for some alloys and high-carbon steels. The hydrogen from the acid reacts with the surface and makes it brittle and causes cracks. Because of its high reactance to treatable steels, acid concentrations and solution temperatures must be kept under control to assure desired pickling rates. Waste products pickling sludge is the waste product from pickling, and includes acidic rinse waters, iron chlorides, and metallic salts and waste acid. Spent pickle liquor is considered a hazardous waste by the EPA. Pickle sludge from steel processes is usually neutralized with lime and disposed of in a landfill. After neutralization, the EPA no longer deems it a hazardous waste. The lime neutralization process raises the pH of the spent acid. The waste material is subject to a waste determination to ensure no characteristic or listed waste is present. Since the 1960s, hydrochloric pickling sludge is often treated in a hydrochloric acid regeneration system, which recovers some of the hydrochloric acid and ferric oxide. The rest must still be neutralized and disposed of in landfills or managed as a hazardous waste based on the waste profile analysis. The byproducts of nitric acid pickling are marketable to other industries, such as fertilizer processors. Alternatives: smooth clean surface and eco-pickled surface are more recent alternatives. In the SCS process, surface oxidation is removed using an engineered abrasive, and the process leaves the surface resistant to subsequent oxidation without the need for oil film or other protective coating. EPS is a more direct replacement for acid pickling. Acid pickling relies on chemical reactions while EPS uses mechanical means. The EPS process is considered environmentally friendly compared with acid pickling, and it imparts to carbon steel a high degree of rust resistance, eliminating the need to apply the oil coating that serves as a barrier to oxidation for acid-pickled carbon steel. References. Bibliography Wang, Lawrence K. Hung, Young T.S.E. Shammers, Naser K., Handbook of Industrial and Hazardous Wastes Treatment 2, CRC Press, ISBN 978-1-4200, 7219-8.